Have
I
you ever
haven't.
heard this before?
I haven't.
Okay.
Got the
Yeah.
idea of what it probably is just by the name.
You heard about that, but you just know the name, but you don't know what's that. Am I right? Is that what you want to see? Yeah, since I cannot see your face, so that's weird.
Uh,
Okay, yeah. Today we will talk about what is a peripheral GPIO and how can we use that. Yeah. Let's start today's class. And yeah, this picture I have already showed to you many times. Yeah, we have micro USB. Let me see. Yeah. Uh, what's this for? Micro USB. Yeah, I think you have already finished lab one. So what is this for? Like a micro USB?
Power and communication.
Yeah, communication like connect with a laptop. Yeah, give a power thing. Yeah, I'm right. Okay, and those are some like main components for the Pico W. The LED here actually. In this semester class, we don't use it, but this is just indicator, like the PQW works well. Like if you give the PQW a power, this LED will be on. And this bottle cell button, what is this? Let us try to recall. Do you know that? Bottles,
It
bottle
lets you flash the what the Pico is going to run.
Flash. Oh, okay. You mean like just refresh the pico? Yeah, yeah, you are right. Actually, yeah, this is flash the pico and reset the pico like that. And what is a voltage regulator?
It keeps the voltage down to a specific amount so it doesn't fry the Pico.
Yeah, like make the voltage down. I usually like we know like if the voltage comes through come into here, it usually fab around fab. But after the voltage regulator, and usually it will become 3.3 like that. Yeah. And here is onboard two magnet flash. This is just like a memory to storage some like data, and you can fetch it very quickly like that. And what's this? RP 2040.
That's
That's the
the
microprocessor.
yeah.
Yeah, yeah, it's microprocessor. But for the Pico W, the RP 2040 include many complex, and we will talk about later in today's class. And crystal oscillator, what is this?
It's a timer. It's a timer.
Yeah, it's full timer. Have you ever heard like for now? Usually, if I know like some students like wearing like a watch. Yeah, actually the watch they have like a mechanical watch, and they also have the crystal like oscillated watch. You know that,
The,
I'm right?
the, the quartz watches.
Yeah. Cross watches. Yeah. And you know, like the cross watches are very accurate. Yeah, as uh, as I know, like maybe like a million billion years, it has a 1 second error like that. Yeah, so that's a reason why some people like a crystal like a watch. Yeah, so this is just the Pico W, like main components Pico for the Pico W. And actually, in our following labs, we will use some of them. And this is just the general information for that. And let's continue today's class. And today we will focus on the like a GPIO, general purpose input output. Yeah, and like a general purpose pins for customer input output operations. You can see this image we have already like saw before and talk about that for like several times. And you can see here, different pins are just like can be considered like except this part. I talk about this part in last class. This part is just like these pins, meaning for the power. Yeah, and let me ask you. I think we will talk about later, like in details for this part, and also the this one, like the ground one, it's just like connect to the ground, and the all the other pins you can see this one, yeah. This one is not like the general purpose input output, but others is just like the green one is a general purpose input output, and we just use those pins to set it as input or output. And you can see we can use this code and to control like if this pins is input or output, and how can we use these pins. And this is just a general purpose input output. But the general purpose input output also has different functions. Like specifically, there are two different functions. And the first one, we call it normal GPIO. Have you ever heard about this normal GPIO? Like a normal GPIO, not a peripheral GPIO. Actually, the normal GPIO just refers to a GPIO pin that controlled directly by GPIO controller peripheral. Yeah. Let me see if I think wait me for a moment. GPIO. Okay, I think I might like use it for the next class. Wait me for a moment. Yeah, here. Let's try to. Yeah. You just need to know, like for now, and the normal GPIO is just like controlled directly by GPIO controller peripheral. And the GPIO controller peripheral is we will talk about later in today's class. And actually, you can see, I have and this normal GPIO always be configured as an input or output, and reads or writes a simple digital values 0 or 1. The GPIO, the CPU controls the pin through GPIO registers. Like we use this code, yeah, like to try to control the pin, like input or output. And the normal GPIO like usually controlled by the controller, the GPIO controller. The GPIO controller owns and drives the pin. Yeah, and this is the normal GPIO. And then today we will focus on the peripheral GPIO. And later I will talk about like what is GPIO controller peripheral and what is the other hardware peripheral. Yeah, actually the peripheral GPIO refers a GPIO pin that is assigned to another hardware peripheral, such as like a UART, like a PWM, SPI, I2C. Actually, those four, like all ADC, those five, you have already done something for those five in homework one, and you know like what are those? Maybe not very clear, but you some sort of you know what are those, am I right? Yeah. For example, UART, SPI, and I2C is just like a try to control how my PCOW like transfer or transfer data with other like hardware device or communicate with other device. And the PWM, what is PWM? Do you know that?
pulse width modulation.
Yeah, that's true. Pulse width modulator or modulation. Yeah, and this is just like try to generate the specific frequency like square signals. Yeah, actually we will talk about this later. And ADC is just like an analog digital converter. Like this thing is just like try to convert analog to the digital analog signal to the digital signal, all the signal. Yeah, and instead of GPIO controller, yeah, you can see if we observe this one, and the normal GPIO is just like the pins controlled by GPIO controller. And this GPIO controller is just try to configure the pins input or output. And the peripheral GPIO, and which means the pins, all the GPIO pins will be assigned to another hardware peripheral, such as those things. Also other like maybe other like PQW things, but not GPIO controller. Yeah, the pin behavior is controlled by the peripheral hardware. The CPU only configures like a peripheral, like the for the normal GPIO, the CPU controls the pins through GPIO register, which means the GPIO, CPU will, if we consider consider the GPIO is a normal GPIO, and which means the CPU will control the pin directly through the GPIO register. But for the peripheral GPIO, actually, what controls the GPIO is just this hardware peripheral. But the CPU is only configures the peripheral. It's just the give it a configuration thing like that. Yeah, for example, the PWM, which means it is just like generate like the specific frequency, like square wave signals, and the CPU will like try to you just give CPU configure it out. What is the frequency? What is the duty cycle? And we will talk about more detail about that. Don't worry if you never heard this before. Don't worry, this is just a general idea about the peripheral GPIO. And then pin may output waveforms like timing signals or data, not just a 0, 1. Yeah, like the input output will not just the 0 or 1, like a 5 volt or like a or 3.3 volt, like a 0 volt, like that. So, yeah. Okay, I think I just like this is just wrong, which means like the another hardware peripheral owns and drives the pin. Okay, let me ask you a question. We have already finished the lab 1. So for the lab 1, which type we use the GPIO, like which type of GPIO we use? Normal GPIO or peripheral GPIO? Yeah, which one? Yeah, if you want to use the GPIO as a peripheral GPIO, you usually use like a specific function, for example, PWM, UART, ADC. So, like you have already finished the lab 1. So, what type of GPIO we have already used, like a normal GPIO or peripheral GPIO?
You've used normal GPIO.
Yeah, that's true. That's true. Yeah. So we have already like used normal GPIO, and we know like when we use the normal GPIO, the GPIO usually be considered as input or output. You have already know that. I'm right. Yeah. From the code. You know, like this pin, for example, the pin 50, we just consider it as input, and we use the button to control it. And for the pin 16, we use it as output, and then we just try to read the output and let the using the output to make the LED on. That makes sense to you? Do you remember that? Yeah. Any questions so far? no question. I'm right. If you didn't answer, I will consider
You
you
have.
have no question. Okay. Yeah, because I cannot see your face. Okay. And so we have already used GPIO as a normal GPIO. And today, yeah, we will focus on the peripheral GPIO. And then we know like what is peripheral GPIO. Like the key idea is just like the another hardware peripheral owns and drives the pins. And then let's try to discuss why this distinction matters. Why we want to divide the GPIO like a normal GPIO and the peripheral GPIO. Actually, you can see. I don't know if you notice that the GPIO controller is also kind of like a peripheral device. Yeah. So why what we want to distinct it? Yeah, actually, a GPIO pin can be controlled by only one peripheral at a time, which means, yeah, do you remember when we talk about that button example, and I talk about that. Yeah, if you want to use a button control the pin input, and you just use a simple circuit, just connect the power with the button and the button with the pin. And I ask you a question. If you want to control a LED at the same time using the button, which means if I just connect the button and I want to use the I want to LED on, I tell you you need to connect the LED to the other pin. Am I right? Do you remember that? And then control the LED through the code logic. Do you remember that? Yeah, that's the main reason because GPL pin can controlled by only one peripheral at a time. So when you connect your circuit, and you just remember, usually one pin is just controlled by one peripheral devices. So you'd better not control connect one pin with different functions, and that will be mess up. Yeah, any questions so far? Okay, let's talk about the details about the differences. Yeah, you can see for the features like the who controls the pins. For the normal GPIO, like the GPIO controller control the pins, and for the peripheral GPIO, it's just a blah blah blah, blah all these things, and maybe there are more like a peripheral GPIO thing, and for the output tap and the normal GPIO usually controls the pins input or output, the digital 0 or 1. And for the circuit, it's just like a 3.3 or 0 volt like that. And for the peripheral like GPIO, you can see the input output should like a data or waveform or timing or analog signals. Yeah, it's not only like digital 0 or 1. And then for the CPU involvement, the normal GPIO, it will directly control the pins input output. But for the peripheral like a GPIO, the CPU is only like a configure focus on the configuration. Yeah, it's just give a configuration for the peripheral GPIO. And the typical use and the normal GPIO just use for the LED button thing. Yeah, because you can see it's just output the input output the digital 0 1, which means our button off on, LED on or off. Yeah. But for the peripheral GPIO, it will be used for communication, PWM, and sensoring. Yeah, that's a reason why we want to try to mix those two, now consider those two are same thing. Yeah, you can see, for this image, you can see like a different peripheral maybe use the same pin, but they have different functions. And for the normal GPIO, it's just very easy, very easy like a thing. And I just input output 0 1 and a control LED button. But for the peripheral GPIO, it will be more complex. Yeah, does it make sense to you? Any questions so far? Okay. The distinction is not about the whether something is a peripheral, but about which peripheral controls the GPIO pin. Yeah. So that's a reason why the why we like divide the GPIO to the normal GPIO and the peripheral GPIO. And then let's talk about what is inside the RP 2014. Actually, the RP 2014, we call it a microcontroller, but a microprocessor, but it now includes the CPU only. Yeah, it includes the CPU cores, like it's just we talk about the like CPU things, and the memory. It also have the like some uh similar like the cache. Yeah, it will like the two. You can see here. We have two magnet flash here, and here we can save more like data here. But inside the RP 2040, there is also a memory, and this memory. Let me ask you a question: is this memory will be quicker than that two magnet flash or slower? Have you ever?
Faster and lower latency.
Huh? Oh, faster and lower listen. Am I right? Is this what you said?
Yes.
Oh yeah, yeah, correct. Yeah, because you can see usually the CPU will like as you know, like the CPU will try to deal with some data and try to do the calculation. If you can just use the like there are some like memories in the CPU, and then CPU can directly fetch the data from this memory, and it will make the calculation thing, computation thing quicker. Does it make sense to you? Does this sense to you? Yeah. And also peripheral modules. You can see these peripheral modules is just like what we have already talked about, like the PWM and the UART, like I2C. Yeah, we will talk about more detail. I will give you more details later. And interconnect and control logic. Yeah, for example, the GPIO controller. We have already talked about that later. And also, all those things all integrated on one chip, RP 2040. Yeah, which means RP 2040 combines computation and hardware control in a single microcontroller. Yeah, does this does this make sense to you? Any questions so far? Wait me for a moment. Let me try to connect my power. Yeah, any questions so far? No question?
I'm good.
No? Okay. Yeah, let's continue. Okay. And for the CPU cores, actually, this is just some like a configuration for the CPU cores, and it is a dual core ARM Cortex M0. Yeah, I think this is you just know that it can execute instructions, run MicroPython or C programs, C++ programs, control the system. Yeah, the CPU core is not a peripheral. It is a central execution unit of the system. Yeah, actually, the CPU core is not a peripheral. It's just the central execution unit of the system. I think this is easy to understand. And then let's talk about the integrated peripheral. Yeah, actually, for we know like the RP 2040 integrated some peripherals, and those are like most like peripherals included in RP 2040. The first one is a GPIO controller. Yeah, it's just control the pins directly, like consider the GPIO as a normal GPIO like that. And UART, Universal Insertion, is sorry, my pronunciation. But you know, like a receiver or transmitter, yeah, we will talk about this later in some specific labs. And we know like this one UART, SPI, I2C is just like different communication types with like Proto, and how the PQW communicate with other hardware device. So those three, and we will talk about those three like later in some specific labs. And this one we will talk about today. And it is, we call it pulse width modulation, which means this one will try to generate the pulse width like signals for just like this one, this one, like yeah, that makes sense to you. Like we call it like a square wave signals. That yeah. And ADC is analog digital converter. Yeah, this one is also very important. Yeah, this one is just like try to convert analog to digital. And we will talk about this very details, very detail in in details in some specific labs. And also timers is just like a try to give different devices a time. Just try let different devices work together in a specific same time like that. And this is just like direct memory access, because you can we know like if the CPU want to execute the data, yeah, it need to like use this peripherals to fetch data or like save data like that. Yeah, peripherals are hardware modules integrated inside the chip that perform specific function under CPU control. Yeah, so like those all those peripherals are hardware models integrated into the RP 2040, and those peripherals will be controlled by the CPU like that. Yeah. Any questions so far? No question? Okay, let's continue.
Nope.
Yeah, actually, you can see for the Pico W, there is the other like module. We call it a Wi-Fi module. Like let me see. Yeah, you can see here, here, or here. Yeah, this is Wi-Fi module. Yeah, and almost all the peripheral are integrated into RP 2040, but the Wi-Fi is not. Yeah, this is just a special one. And actually, it is the Wi-Fi is also like a peripheral module, but I think why the Wi-Fi did not included into the RP like 2040. I think because the Pico there is the other like one called Pico, and the Pico did not does not include Wi-Fi. So I think it is easy for design. So it just like put the Wi-Fi like outside the RP like 2040, and make it easy to use. Yeah. So you can see important distinction for the Wi-Fi and other things, and you can see those peripherals inside the RP 2040, but the Wi-Fi radio is just an external chip. It outside the RP 2040, and also the like the actually the Wi-Fi communicate via like SPI peripheral. Yeah, the Wi-Fi we know like it also will communicate with other devices. If we began to start the final project or other like I think there is at least one lab we will talk about Wi-Fi, and we will know like the Wi-Fi communicate via like SPI peripheral. Yeah. Okay, any questions so far? No? Okay. And those are some like general information for the PQW. And our most important thing we talk about is like a peripheral GPIO. And today we will talk we will like around like a peripheral GPIO to finish our lab 2. And our lab, let's talk about like what will be included in lab 2. And the topics covered will like a GPIO input and output. Yeah, just a normal GPIO input or output. We will continue to do something for the normal GPIO and try to understand the normal GPIO like deeply. And we will like consider push button as a digital input. And also we will try to like we talk about pull up and put on resistors a lot, and I'll try to feel how important those two are. And also we will switch bounce and debouncing, and try to like improve like a button circuit and through the like code. And then we will like try to use PWM to control the LED. We know in the lab one we try to control the LED using the code and try to sleep. Let the CPU sleep some specific time and then toggle the LED. But it's not that smart. And also you can see if you want to adjust the like frequency, you need to. It's not easy for you. For example, if I noticed some students the code like if you want to like adjust the specific set the specific frequency, you need to like minus something for the frequency. Also, I noticed some students just use a list to fetch different frequency, and then later, it's not very convenient. So we will like learn how to use PWM to control the LED, and also. And finally, we will try to learn like the GPIO pin adequacy, and it's just like when we like finish use GPIO pins, and we need to give it a safe clear up. Otherwise, there are some like risks. Yeah. Okay, our learning goals for lab 2 is just understand how GPIO pins interact with the hardware and software on the Pico W. Okay, let's try to continue to talk about that. And you can see, like firstly, we will like learn how to like use the GPIO as a digital input. Actually, we have already talked about this circuit like in last class, like a push button. And you can like we know like if you want to use the button to control these pins, and the best thing is don't connect this one with a LED. I know like some students want to connect LED to show if my button clicks like works or not. If there is a LED, and it will be obvious. But like I said, the LED works in a nonlinear way. So if you want to use the LED to display, or if your button works or not, and you need to use another pin to connect LED, and then if you can use code to give a right logic to control that. Actually, you will finish it in lab 2. And for the key idea for this digital input using like a push button. A push button is a mechanical input device, and it is change the voltage level seen by the GPIO pin. You can see here it is directly connected the 3.3, and then if you push a button, and the this will connect to the pin and give the pin a 3.3. Otherwise, it will be 0. And the GP50 used as a button input in this lab. Okay, any questions so far? You will try to build this circuit, try to use the button as an input. And then, okay, and in our lab, we will talk about why the resistor is critical, this one. Okay, actually, this one, why it is very important. Actually, you can see a push button is a mechanical input device. It changes the voltage level. Sorry. I think this one is similar with the like the previous one. Sorry, because just now I think I removed these slides because I want to you think about why it is it is very critical. Actually, I have already talked about something in the lab instruction. First thing, you need to connect this resistor. Don't remove it. Yeah, and then after you finish this lab, please tell me why this resistor is crucial. Actually, I don't want to tell you here for now. Tell you like for now, and I want you to create your own circuit and try to find out the answers by yourself, and then we will talk about these questions in Wednesday. Does it make sense to you?
Yes.
Okay, and then this is just like the internal pull down resistor, and actually those we have already talked about a lot. Yeah, and we use this code, and actually this like if you try to use this configuration, which means you just connect this pin with a pull down resistor, like inner the pico W like that. Yeah, this one will ensure the pico pins has a defined low state when not pressed. This action will prevent floating input, and like why use internal pull down? Yeah, actually you can see here we have a new word, internal. Yeah, in last class we talk about pull down resistor, pull up resistor, but here is internal, which means there is a internal pull down and pull up resistor inside the pico W. Yeah, and if you want to use it, you just need to configure here. Use this configure using P dot pull down or P dot pull up. And this why use internal pull down removes need for an external resistor and simplifies wiring. Yeah, actually, if you want to, actually you can connect a pull down resistor by yourself through here, but you can use this also. This action can remove need for an external resistor and simplifies wiring. Does it make sense to you? Any questions so far? No questions? Yeah.
Nope.
Okay. Okay. Let's talk about switch bounce and software debouncing. What is a switch bounce? Yeah, actually, I don't know. I don't know if you notice that when we when we did the button lab in the lab one, if you push the button, sometimes it will not print the like button press. Sometimes if you push the button, it will print twice or even 3 times. Did you notice that? Did you notice that? I don't know. I think some students,
Yes.
yeah, in that situation we call it switch bouncing. Yeah, actually you can see mechanical connects do not close clearly. Yeah, and cause rapid high-low transitions. Yeah, you can see if you press a button, like there will be a switch bouncing situation, and it will like the mechanical like connects do not close like clearly. Is it will result you just press one time, but there are the like pico W will detect like several times press, yeah, like that, because it will cause rapidly high-low transitions. Yeah, which means one transition is just like the pico W connect one press, am I right? Yeah. So we want to try to remove like this situation, like try to improve this situation. Then we will like yeah, this one will like have some problem. Pico may detect multiple presses for one physical press. Yeah, you have already noticed that. And then how to fix it? We try to use software debouncing. Yeah, we try to use like a code to fix it. And then let's try to figure out how can we like yeah, in this lab you will know how to like use software debouncing to remove that situation. And then also in this lab we will like counting the button presses, and here I will give you this is a question, and you will like find out how can we use software debunking to improve that question, and then we also will try to count button presses and use a counter variable to track presses, and output will via print. And why this matters? It will demonstrate input handling, demonstrate state tracking, and demonstrate user feedback. Yeah, and you are required to implement this as part of the lab. And you just read the instruction and try to figure out. Yeah, don't worry. And in the instructions, there is a very clear steps. And also, I will give you some code, and you can write your own based on the code I will give you. And you need to try to count button presses, and then we will try to use RIQ functions, and this is edge detections. You can see we use sleep. Let's try to talk about the what is RIRQ exactly, and then we will talk about the difference between this one and the previous one, like the previous in the lab one. What is interrupt? We call it IRQ. Actually, the hardware detects a single change, calls a function automatically, and why use IRQ instead of sleep? Yeah, you can see when we use sleep, and then we can try to control the button, try to control the LED. But here we use interrupt to instead of the sleep. The instead when we talk about sleep, we know if we execute sleep, and the CPU will be taken up, will be set as idle, and it will not do anything. Am I right? Yeah, but the RIQ is now working like that. If you use RIQ, it no blocking and more responsive and more realistic embedded design. When the RIQ will be executed, it will be triggered when reason edge low to high, which means if you press the button and from the low to high, and then the RIQ will accurate. Here you can see this is a button. Yeah, it's same with the button we define in the previous lab. Here is a function. Yeah, it's a this function is just every time when you execute this function, and it will add one. And then for the this button will have the RIQ request, which means every time when the single signal change from low to high, it will execute this function. That am I clear? Which means if I click a button, it will click one button, and then this function will execute it. That makes sense to you? Any questions so far?
No, ma'am.
No question. I'm right.
No, ma'am.
Okay.
No.
Let me ask you a question. If what's the function? What's a function for this loop? What does this loop do here? Yeah, since we don't need since we want to use IRQ to replace sleep. What's it? The first question is why this loop is here.
Make sure the program stays executing.
Yeah. Makes a program is continuously running. Am I right? That makes sense to you. If try to imagine if you remove this one, uh, I cannot try to remove. If you remove this one, which means if your code will run one time, it will finish. That makes sense to you? That makes sense to you? And then, sorry. And then if you add this, like, I want to try to, where can, okay, sorry. And if you add this well, which means your code is always executed. Am I right? That makes sense to you? Because there is a where true. Sorry, I don't, I cannot. Let me try to wait, where I want to I want to try to like erase it, but this is my first attempt. Sorry. Okay. Can you see this code clearly? Everyone, can you see this code?
Yes.
Yes, ma'am.
Okay, yeah. So which means if you remove this where, which means your code is just will be executed one time. Am I right? After you execute this code, it will finish. But if there is a where and here is true, which means your code is always executed. That makes sense to you? Any questions so far? Okay, and then the sleep is just like you can see if your like CPU is always executed, and you will like you will make your CPU runs always, and this sleep is just give you like CPU time to have a rest like that. But no, but if you finish this lab, you will know like whenever it is if once you click press a button and this function will be executed. Yeah, you will know that, and I will leave this to you. And please and this is just like a IRQ via status checking. And you can see here, we use IRQ. And here, if you use this function, like just if button press, and then I add one to the n, actually, the logic is the same thing, am I right? That makes sense to you? The logic is the same thing. Am I right?
Yes.
Yeah, but you will try to find what's the difference. Yeah, we will talk about in on Wednesday. Yeah, on Wednesday you will have a presentation. Okay, and also like we will use PWM to control the LED brightness, and can you give me 2 more minutes? Yeah, we talk about the PWM is plus like pulse width modulation, control the average power by adjust the duty cycle, and we will like make the LED bright and motor control like also like if you use PWM, there are two different parameters, frequency and duty cycle. What is frequency? Frequency is just like a per second how many cycle, am I right? This is frequency. That makes sense to you? For example, this is your like single, and this is t, and this is just 1 second, and this is just 3, am I right? Which means our 3 cycles per second. That makes sense to you? This is frequency, am I right? What is duty cycle? Duty cycle, have you ever heard duty cycle before? Yeah,
Yes.
yeah, duty cycle is just one period, like one period. Yeah, if your high is half is one kind of situation, but your sec is maybe the high will more and the low will be less. It's also one cycle. Am I right? This is duty cycle. That makes sense to you? It's how like how percentage in one cycle is high. This we call it a duty cycle. Does it make sense to you? Any questions so far? Yeah, and then you use this code, try to like adjust your frequency and your like duty cycle, and you will find it in today's lab, and I will give you the instruction later. Yeah, and this is just the PWM in code, And also, there is a challenge. Button controls the PWM. You try to use the button, press increase the LED brightness, and option second button decrease the brightness. And there are some like concepts combined GPIO input, IRQ, PW output, and bounds checking. Yeah, and this is our challenge. Okay, this is like the pin etiquette, and it is try to give you how after finish the lab, try to clean up pins on exit, set outputs low, and set PW duty circle to 0, and to protect the PQW. Yeah, and then this is our lab takeaways. And by the end of this lab, you should understand the safe GPIO wiring. You can read the buttons input reliably. You can control outputs using PWM, and you should know why clean up matters. Yeah. Important thing, GPIO is simple, but misuse can damage hardware. But luckily, today we will not use your real PQW. You will use the lab simulator. Let me try to, yeah, I will send these slides here. Yeah, you can see if you click like open this website, and if you use the other one before, and you can also shows me the other one that's using the other simulator. That's totally fine, and you can use like example here. Yeah, this is just a result, and also you can see this is an LED. Yeah. Yeah, this is just a very simple lab, and you can put your code here and try to run it. And yeah, I think it's easy. And also you can try to put add a button and add a resistor, and for the resistor you can adjust the value. And uh, if you have any question about this simulator, and please let me know. And yeah, I will upload the lab 2 instruction before 2 p.m. And for today's lab, I will be available on Zoom from 2 to 25 to 60:25. You don't need to stay on Zoom on the entire time. Please join the meeting whenever you have question about lab 2 or the like simulator. Yeah, during your lab time, you are required to show me your lab results using the lab simulator via Zoom for checkoff. Does this make sense to you? Yeah, any questions so far?
Oh man.
Okay, I will upload the okay for the like attendance. I think I need to record the attendance if okay, for now we have 11 students. Yeah, I hope no students offline. Okay, I have already recorded the attendance. And yeah, I will like upload the slides, video, and the lab instructions later on Blackboard. And you need to show me your result via Zoom this afternoon. And you don't need to be on the Zoom. Yeah, always. That makes sense to you? Okay. See you. Yeah, have a safe time.